Hi everyone. In this video, let us see some graphs of quadratic polynomials and let us make some observations. Suppose we want to write examples of quadratic polynomials having two zeros or quadratic polynomials having only one zero or quadratic polynomials having no zeros. How can we immediately write some examples? First, let us observe the graphs and later we'll come to some conclusions so that we can write examples for quadratic polynomials having two zeros, having only one zero, and having no zeros. First, let us observe this graph. The general form of quadratic polynomial is p of x is equal to ax square plus bx plus c. Suppose we have p of x is equal to ax square only. This is also a quadratic polynomial. So here we have some examples and graphs are also drawn here. Here y is equal to 1 by 2 x square. This blue curve is y is equal to 1 by 2 x square. This green curve is y is equal to x square. The violet curve is y is equal to 2x square. Now what do we observe? Here we have p of x is equal to ax square. The values of a are varying here. A is 1 by 2, a is equal to 1, a is equal to 2. So what is happening? The curve is simply bulging. When a is 1 by 2, the curve is bulgier. When a is equal to 1, opening of the curve is getting thinner. When a is 2, the opening of the curve is further getting thinner. That means, say for value of x as 1. So here we are taking x is equal to 1. For x is equal to 1, here the value of y for this curve, when x is equal to 1, y is equal to 1 by 2. For this curve, x square, polynomial is x square. When x is equal to 1, y is equal to 1. But for this curve, when x is equal to 1, y is equal to 2. When a value is increasing, we are getting increased values of y or increased values of the polynomial for same value of x. The curves are intersecting x-axis at 0. So the 0 of all these polynomials is x is equal to 0. Though a is varying, the 0 of the polynomials is not changing. So the 0 of the polynomial is not simply dependent on a. Now let us look at some other curves. Here we have p of x is equal to ax square plus some constant. We are missing x term here. X term is missed. But this one, ax square, here x square is a complete square of x. So p of x is equal to ax square plus some constant. So here x square is a complete square in x variable. So here also we are getting same vertex for all these curves, but the value of y, that is value of polynomial at vertex is 1 here. When x is equal to 0, y is becoming 1 for all these polynomials. The value of polynomial is equal to 1 at x equal to 0. So what we observe here is when there is a complete square, here we have a complete square, here we have a complete square, here also we have a complete square. A complete square plus a constant, a positive constant here, plus constant. If the polynomial is like this, a complete square plus a constant, that means a positive constant here, then these curves are not intersecting x-axis. X-axis is here. These curves are not intersecting x-axis. So these curves do not have zeros. No zeros for these polynomials. So whenever the polynomial is in this form, p is equal to say a x square plus some constant. Here it is a positive constant. Then that polynomial doesn't have zeros. There are no zeros for that polynomial. Let us see some more examples. Here also we see this is a complete square in x, and we have plus some constant. Complete square plus constant. So this has no zeros. This polynomial curve is not intersecting x-axis here. Also this one, x minus 1 whole square. This is also a complete square. X minus 1 whole square plus 1. Here the vertex is shifting to 1. Because here we have x minus 1 whole square, the vertex is shifting to 1. After complete square we have plus 1 here. So plus constant. The positive value of constant is here also in this curve. So this curve is also not intersecting x-axis here. So these curves have no zeros. These polynomials have no zeros. So what do we observe here? When we have a polynomial in this way, a complete square plus some constant, that means the value of the constant is positive. When this is positive, when a here is positive, this is positive, and the constant here is also positive, then no zeros. If this is negative and the constant here is also negative, then also no zeros. See here another graph. The polynomial here is x square minus 1, a complete square x square minus 1. Here a is there, a is positive 1. Here we have positive value and here we have negative value. A complete square is here. So P of x is equal to a into some complete square plus constant if this a is positive and the constant here is negative, then we have zeros. Then we have two zeros. See here we have zeros for this polynomial, and for this polynomial also here it is a complete square and a here is positive but the constant here is negative. So this also has two zeros. If a is negative and the constant is positive, then also the polynomial has two zeros. Here again we can see we have a complete square here. A value is positive and the constant here is positive. Both are positive. So no zeros. These curves are not intersecting x-axis here. Now let us see try this one question. Write three polynomials that have two zeros each. We want to write polynomials that have two zeros. So our polynomial should be like this. P of x, a complete square here, and here we have positive sign. So this should be negative, say 1. P of x is equal to x plus 1 whole square minus 1. This means x square plus 2x plus 1 minus 1. This is x square plus 2x. This has two zeros. Or say P of x is equal to x minus 1 whole square minus 5. This is equal to x square minus 2x plus 1 minus 5. This is x square minus 2x minus 4. We have written this one in ax square plus bx plus c form. We have written this one in ax square plus bx plus c form. So this has two zeros. Because here we have a complete square and this a value here is positive and the constant after complete square is negative. So this will have two zeros. Let us say another one. Say x minus 2 whole square minus 6. This is x square minus 4x plus 4 minus 6. This is x square minus 4x minus 2. This has two zeros. Then another question here. Write one polynomial that has one zero. write some polynomials having only one zero. Then how do we write? Polynomials having one zero only. Our polynomial should be in this form, a complete square. P of x is equal to some a into a complete square. Let us say P of x is equal to 2x square. This has only one zero. Say P of x is equal to x minus 1 whole square. This is x square minus 2x plus 1. This has only one zero. Say P of x is equal to x plus 2 whole square. This becomes x square plus 4x plus 4. This has only one zero. Another question is, how will you verify if it has only one zero? We are writing polynomials that has only one zero. How can we verify that it has only one zero? How are we writing here? Say let us take this one. If we want to find zero of this polynomial, we have to equate P of x to 0 and solve for x. X minus 1 whole square is equal to 0. So x minus 1 is equal to 0 again, or x minus 1 is equal to 0. So x is equal to 1 and again x is equal to 1. So we are getting two zeros same. The two zeros here are equal. So we have only one zero. So here in this is a complete square in x. X plus 2 whole square is equal to 0. To find zeros of this polynomial, let us equate it to 0. So x plus 2 whole square is equal to 0. This gives x plus 2 is equal to 0 or x plus 2 is equal to 0. So x is equal to minus 2, again minus 2. We have two equal zeros. So this has only one zero. Let us take another question here. Write three polynomials. Write some polynomials. Let us say write some polynomials that have no zeros for x that are real numbers. So there are no real zeros. How can we write some examples? How can we write some examples of the polynomials that have no real zeros? No real zeros. Let us say P of x is equal to x minus 1 whole square plus 1. Here a value is positive. A is equal to plus 1 here. Here the constant after complete square is positive. So let us try to find the zeros of this polynomial. We equate the polynomial to 0. X minus 1 whole square plus 1 is equal to 0. So x minus 1 square is equal to minus 1. This implies x minus 1 is equal to plus or minus square root of minus 1. Left side we have square here. When we square root left side, we also square root the right side. So x minus 1 is equal to square root of minus 1. But square root of minus 1 is not real number. So this polynomial has no zeros. Let us take another example. P of x is equal to x plus 1 whole square plus 2. So here we have positive a. Here the constant after complete square is plus 2, positive constant. If we want to find zeros of this polynomial, we have to equate the polynomial to 0 and find x. X plus 1 whole square plus 2 is equal to 0. So we get x plus 1 whole square is equal to minus 2. If we take square root on both sides, we get x plus 1 is equal to plus or minus square root of minus 2. So square root of minus 2 is not a real number. So this polynomial has no zeros. Third one, let us say p of x is equal to x minus 4 whole square plus 3. If we equate this polynomial to 0 and try to find zeros of the polynomial, x minus 4 whole square plus 3 is equal to 0. X minus 4 whole square should be equal to minus 3. Taking square root on both sides, we get x minus 4 is equal to plus or minus square root of minus 3. Here, square root of minus 3 is not a real number. So, this polynomial has no zeros. See you in next video.